Hello, and welcome to Module 13.5, the exterior angle theorem. Our objective for today is that I can find the measures of interior and exterior angles in a triangle by using the exterior angle theorem. What is the exterior angle theorem? Well, we talked about this a little bit yesterday where I introduced what an exterior angle is. So now let's look at the theorem itself and what it tells us. So the measure of an exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. So in the model off to our right, the measures, our two remote interior angles are those two. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. Now, let's look at this model and kind of explore why this is the case for a moment. If I look at and just zoom in on this portion here, what do I know about the relationship between angles 3 and angle 4? Well, this is a straight line, and we have it intersecting with a ray. All right, so this gives us two separate angles, right? Angle 3, angle 4. What we know about these angles is that angle 3 and 4 are we're not going to rewrite them, but we know that this is a linear pair, right? It's two angles that are adjacent to each other that make up a straight line. They are a linear pair, so what does that mean? They equal 180 degrees. Okay, so then if we take that away and we look at the fact that then we have a triangle, well, angle 1 plus angle 2 plus angle 3 is equal to 180. And we've got angle 3 plus angle 4 also equals 180. So if we've got angle 3 being added to something and it's equaling 180, then that means these two angles have to be the same as that angle, right? So we're going to substitute angle 1 and angle 2 in, and we're going to say these two have to be the same. Angle 4 must be the same as angles 1 and 2 combined, because when you add angle 3 to each one of them, they equal 180 degrees. All right, so let's take a look at the first two on this page. So we've got 58 and 74. These are our two remote interior angles, and we're trying to find what x is. So we're going to do 58 plus 74, and that's going to equal 132 degrees. Now, could we do this another way? Yes, you could find what the third angle is in the triangle using triangle sum theorem. And when we do that, right, you do, that would be separate work here, but if we did 74 plus 58 plus x equals 180, so we would find that x is going to be equal to 48, and actually let's do y because it's the interior angle. So we could find that that is 48 degrees, and it's supplementary to the outside one, so 180 minus 48 gets us 132, right? We can work this a couple different ways, but if we can use the exterior angle theorem, we can shorten our work a little bit and make it a little bit easier as we're going. All right, let's look at this second one here. We've got remote interior angles here because they're not touching angle Y. So we're going to do 103 plus 51, and we are going to get 154 degrees equals Y. All right, so 154 degrees is our Y value. Okay. So let's go ahead and go to the next page where, oh, look, it's one of these problems that we have an expression that we're working with instead of just values. But again, we have our remote interior angles are these two, and this is my angle that I have on the exterior. So we're going to set it together. 135 is going to be equal to 18x plus 15x plus 3. So combine like terms, 18 plus 15. 18 plus 15 is 33x plus 3. Now we subtract 3 from both sides. We get 132 is equal to 33x. And then we divide both sides by 33. And we get that 4 is equal to x. Our x value is 4. No degrees, just 4. Now, if we want to find the measure of angle D, okay, angle D is 18 times 4. So 18 times 4 is 72 degrees. The measure of angle C, 15 times 18 plus, 15 times 4 is 60, plus 3 is 63 degrees. And our last one, the angle DBC. So starting at D, going to B, going to C, right? Two different ways we could get this. We can use triangle sum theorem, or we can use the fact that this is a linear pair again. Going back to that vocabulary from a couple lessons ago. So a linear pair means they add up to 180. 180 minus 35 is going to get me 45 degrees. Or we could have done 180 minus 72 minus 63, hit enter on the calculator, and you get 45. Either way, you're using a calculator on this, so the work is going to be fairly quick for you, and it really doesn't take much to add in, those extra couple keystrokes to do the additional subtraction from 180. The choice is yours. I don't care. All right, let's take a look at the bottom problem. Why don't you guys work this one on your own and then check your work against mine. All right, so I'm going to set my two terms on the inside equal to my exterior angle. So I'm going to have 106 minus x equals 7x plus 4 plus 9x. We're going to combine like terms on the right. 106 minus x equals 7x plus 9x is 16x plus 4. Okay, we're going to subtract 4 from both sides. Okay, and we get 102 minus x equals 16x, getting a step ahead of myself. Add x to both sides. Honestly, you could have done this in either order. 102, not 120, 102 is equal to 17x, which I divide by 17, and I get that 6 is equal to x. All right, so now the measure of angle J. We've got 6 times 7 plus 4. 6 times 7 is 42, plus 4 is 46 degrees. Angle K. 9 times 6 is 54 degrees. Angle KLJ. So starting at K, going to L, going to J. Angle KLJ. 180 minus 46 minus 54 gets me 80 degrees. And then my last one is going to be angle JLM. So starting at J to L to M, JLM, we know we can substitute there. And 106 minus 6 is 100 degrees. All right, we're going to turn to the next page and we're going to do some more practice with this. So I want you to do these first 3 problems as a U-try problem. Do these 3 on your own and then check your work against mine. All right, First one, we've got 55 plus 60, straightforward. We get that our angle, our exterior angle, is 115 degrees. Okay, next up, we've got y plus 25 equals 70. And then we subtract 25 from both sides of our equation, and we get that y is going to be equal to 45 degrees. All right, now if we're looking at this one, we're looking for measures of angles 1, 2, and 3, and we are using exterior angle theorem again. So if I want to find the measure of angle 1, that is a linear pair. So I'm going to do 180 minus 135, and I'm going to get that angle 1 is 45 degrees. All right, I'm going to show my work here. 180 minus 135, and that gets me 45 degrees. So now we're going to write that in here, erase my arc. I'm going to write that in here. This is 45 degrees. So now I can use exterior angle theorem. 45 and 90 is going to be equal to angle 3. So 45 degrees plus 90 degrees is 135 degrees. Now, if we want to find angle 2, we can either use the fact that it's a linear pair, or we can use triangle sum theorem. Either way, you're going to find that angle 2 is 45 degrees. Okay? And again, this is a picture that is somewhat deceptive of how the triangle's measurements actually add up. It's not one that is drawn to scale. All right, now last problem. We have this like bow tie that we're going to look at. We need to figure out what we're going to do with it. So I have angles A, B, and one of the angles of C identified, and they're all in terms of x. So I can work with that, because if I just focus in on the fact that this is a triangle with an exterior angle, right? Here's our exterior angle, and then these are my two remote interior angles. So I can use that, and I can say 3x minus 21 is equal to 2x minus 21 plus 42. Now, I combine like terms on the right-hand side. I get 3x minus 21 is equal to 2x plus 21. Then I'm going to subtract 2x from both sides. X minus 21 equals 21. And then I need to add 21. X is going to equal 42. All right, so we can start filling in our table. Our x value is 42. That's what we just calculated. So now we're looking for the measure of angle ABC. All right, so let me erase some of my drawings on our graph. We're looking for the measure of angle A to B to C. Right? And we can see why we're labeling these by their letters and their vertices, because like at point C there's 4 different angles that could be represented by that C. So we're going to be looking at what they're named instead. So angle ABC, that 2x minus 21. So 2 times 42, which is 84, minus 21 is 63 degrees. Our next one is angle BCE. So starting at B, down to C, and then out to E. BCE. So it's this exterior angle here that's represented by 3x minus 21. So we do 3 times 42 minus 21, and we get 105 degrees. All right, cool, cool, cool. Now it doesn't ask anything, and the other interior angle, BCA, it doesn't ask about anywhere, so we don't have to worry about that. But let's look in now at the second set of triangles. What do we have going on here? Well, let's draw in our triangle again, just kind of highlight it and emphasize it. We have an exterior angle, and we have two remote interiors. So you do 105, what we just calculated, is equal to 2y plus 3y. Okay, 2y plus 3y. So we've got 105, and we combine like terms, so that equals 5y. And then we divide both sides by 5, and we find that 21 is equal to y. So if I'm looking then for angle CDE, so C down to D and over to E, we're going to do 3 times 21, which is 63 degrees. And if I'm going to be looking at angle DEC, so starting at D, going to E, back to C, so that's 2 times Y, 2 times 21 is going to get me 42 degrees. All right, that represents the end of our notes for this module. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.